Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hello there, Herman and Corn. So one of the great beauties of Claude Code as a system is that it takes the power of a traditional agentic orchestration framework, which has historically involved lots and lots of Python. And instead, it reduces it to Markdown for the most part. So we can configure agents, skills, sub-agents, all these nuts and bolts of agentic AI workflows using a language that's extremely easy to write. And everything from the agent selection to the actual creation of new sub-agents can be done by AI itself. So it's a very, very meta system in the sense that AI can create part of the system independently, execute parts of it autonomously, but the barrier to entry for the human who is overseeing it is greatly reduced through Markdown being a very approachable interface. I think that's its beauty anyway. I've often thought, what is it about Claude Code that I find so fascinating, captivating, and why is it taken over? And I think that's exactly it. Probably more people than they'd like to admit are not comfortable with the idea of creating huge multi-agent systems by hand with Python. It was a very, very big ask for those who want to just explore agentic AI. What I'd like to talk about in today's episode specifically is there was something I saw on X. We've often seen when we're using Claude or these agentic frameworks, they're becoming increasingly good at showing you the actual what's going on in the process. So you'll see the orchestrator. Claude is the orchestrator, or Gemini in the case of Gemini, or Codex, etc. You'll see it invoke a sub-agent. You'll see the sub-agent or the orchestrator using tooling like MCP. You'll see the amount of tokens that have been consumed, and you'll see how long it's been running for. Someone posted a screenshot of an agent system that had been running for essentially 24 hours through the orchestrator sending out jobs iteratively, and the main process still keeping going. And that was really interesting to me, because we talk about agents in the sense of them being task-driven workflows, whether they're initiated by a task definition, rather than being, we tend to think of those kind of fully autonomous agents that might be triggered by something else and running all the time as two very different entities. But if you can think of these of some of these agent frameworks as one individual process lasting more than a day, it really changes the picture of what a task even means. It's to state the obvious, it's greater than a workday. You would create an agent working on a big task, maybe building a website. It would have this delegation process, and without you even needing to clean up the context, you'd come back tomorrow after you'd slept and woken up to find your agent maybe still working through the task, delegating parts of it. So it's a really amazing concept, and I think that it will definitely be the future as we get the actual tooling ready for that to happen. The challenge at the moment for that kind of thing is that the main orchestrator has to handle its context efficiently. And this is a very technical point, I guess, for those who are looking at the different tooling on the market. But the core idea of sub-agents is that they have their own context windows. So the orchestrator hands out, basically like an orchestrator in a production line or a manager, it delegates tasks. But the orchestrator itself has to have some persistent context for the project. And that's where, even if all the orchestrator does is keep the details in mind and hand things out, what seems like a potential challenge to me in the engineering here is that at some point that orchestrator is going to hit its own context window. Even if we think of of a mid-level manager handing out tasks all day. If that mid-level manager can only remember the last 100 tasks it delegated, at some point its own memory is going to compromise the whole orchestration picture. So the first thing I'd like to get into is how that challenge might be remediated or dealt with, because it's if that can be a non-issue, and we have these subagents with their own 2 million plus context windows, then it really does seem like the sky is the limit. The second thing I'd like to talk about, Herman and Corn, is how far this process can actually be nested. In Claude Code and most agentic systems, we're talking about first level nesting. In other words, we can create subagents, but we can't, the tooling doesn't natively support creating sub-agents and sub. I mean, we could go on recursing. My question is, as we see these agentic frameworks, and maybe some of the more powerful ones like Crew AI already support this, but what would be potentially one solution to context is we don't just have one orchestrator and a huge amount of subagents, which right now provides its own context problem because the agent definitions add to the context weight. But we had this literally branch model by which the orchestrator is the CEO. There's a department of operations, department of QA, department of, and you can imagine the different departments in non-coding contexts. And each of these might have their own subagents. And in enterprise workflows, we might be able to model out an agent mirror organization. So those are some pretty big ideas and questions, I know, Herman and Corn, but I'd love to get your take on how those are actually being implemented today in some of the agentic frameworks we're seeing, namely the context challenge for the orchestrator and this idea of nesting and recursion. How far do some of the current frameworks go, and how far do you think we can actually take it?
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I'm sitting here in our living room in Jerusalem with my brother, the man who probably has more browser tabs open than most data centers.
Herman Poppleberry, at your service. And you are not wrong about the tabs, Corn. I was actually just digging into some new benchmarks for long context retrieval before we started. It is a wild time to be looking at how these systems remember things, especially with the new inference time-scaling models we have seen this year.
It really is. And speaking of remembering things, our housemate Daniel sent us a voice note this morning that perfectly taps into that obsession of yours. He's been playing around with agentic AI frameworks, specifically something called Cloud Code. Not the old Google IDE extension, but that new Markdown-based orchestration layer. And he has got some pretty deep questions about the architectural limits of these systems.
I love that Daniel is diving into Cloud Code. It is such a fascinating pivot from the heavy Python-based orchestration, like the early versions of LangChain or Crew AI that we saw for the last couple of years. Moving toward Markdown-based configuration is one of those things that sounds simple, but it actually changes the whole developer experience by separating the logic of the task from the messy code of the implementation.
Exactly. But as he points out, the simplicity of the interface does not solve the underlying physics of the models. We're talking about two big things today. First, that persistent memory problem. How does an orchestrator stay sane over a 24-hour task without its context window overflowing? And second, the idea of nesting agents. How deep can the rabbit hole go? Can we actually build what he calls agent mirror organizations?
Those are the right questions to be asking in 2026. We have moved past the point of just asking a chatbot to write a poem. Now we are asking it to run a project for a week. So, where do you want to start, Corn? Should we look at the memory bottleneck first?
Let us start there. Daniel mentioned seeing a screenshot of an agent system running for 24 hours straight. To a lot of people, that sounds like a lot of tokens. If the main orchestrator is the one holding the clipboard and directing all the sub-agents, how does it not just run out of space or start getting confused as the day goes on?
It is a massive challenge. Even with the context windows we have now, which, let us be honest, are huge compared to 2 years ago, with some models hitting 10 million tokens, they are still finite. If you are using a model with a 2 million token window, you might think you are safe. But if that orchestrator is receiving detailed logs back from 10 different subagents every hour, you can burn through that faster than you think. You hit what we call the context saturation point, where the model starts ignoring the system prompt in favor of the most recent logs.
Right, and it is not just about the total count, it is about the density of information. If I tell you 1,000 things, you might remember the first and the last, but that middle part gets hazy. Models have that same problem with middle-of-the-context retrieval. So, how are frameworks like Cloud Code, or even the more complex custom stacks handling this without the orchestrator just lobotomizing itself every few hours?
There are a few clever strategies being used right now. One is what I like to call the rolling summaries, or the executive summary pattern. Instead of the subagent sending back a raw transcript of everything it did, it is required to provide a structured state update. The orchestrator does not need to know that the subagent had a syntax error 3 times before it got the code right. It just needs to know the task is complete and where the file is located. We are seeing this implemented as semantic caching, where the system only keeps the delta, the change in state, rather than the whole history.
That makes sense. It is like a manager who only wants the bullet points, not the play-by-play. But does that not risk losing the nuance? What if the reason the subagent failed initially contains a piece of information the orchestrator needs for a different task later?
That is exactly where the friction is. If you compress too much, you lose the breadcrumbs. This is why we are seeing a lot of work in what is called hierarchical memory management. Instead of everything living in the active context window, you use an external scratchpad or a vector database. When the orchestrator needs to recall something from 12 hours ago, it does not look in its immediate memory. It triggers a tool to search its own history. It is basically RAG for the agent's own life story.
So it is essentially giving the AI a long-term memory that exists outside of its brain, for lack of a better metaphor. We talked a bit about this back in episode 150 when we were looking at mesh networks and data flow, but applying it to agent logic feels much more personal. It is like the AI is keeping a journal of its own actions.
Precisely. And in Cloud Code specifically, because it uses Markdown, it is very easy for the system to append to a persistent state file. Think of it as a shared document that the orchestrator and all the agents can see. The orchestrator can clear its own local cache to stay fast and responsive, but as long as that Markdown state file is being updated, the context is never truly lost. It is just archived and searchable. It is the difference between keeping everything in your head and having a really good filing cabinet.
I wonder though, even with that, do we not run into a latency issue? If the orchestrator has to go out and search its journal every time it wants to make a decision, does that not slow the whole organization down?
It definitely does. There is a real cost to retrieval both in time and API credits. But the alternative is the system becoming what researchers call distracted. If the context window is too full of irrelevant details, the model starts to follow the wrong patterns. It is actually better to have a slightly slower, more focused orchestrator than a fast one that is hallucinating because it is overwhelmed by its own history. In 2026, we are optimizing for correctness over cadence.
That is a great point. It is the difference between a frantic manager who remembers everything but understands nothing, and a calm one who knows where to look up the details. Now, Daniel also brought up this idea of nesting and recursion. This feels like the next logical step. If one orchestrator is good, is a hierarchy of orchestrators better?
This is where it gets really nerdy and really exciting. In current frameworks, we usually see a flat structure. You have one boss and 5 workers. But Daniel is asking about sub-agents, basically modeling an actual corporate hierarchy. The CEO agent talks to the VP agents, who talk to the manager agents, who talk to the developer agents.
I can see the appeal. It mirrors how humans organize complex tasks. We do not have one person managing 1,000 people directly. We break it down. But AI is not human. Does that structure actually work? Or does the message just get garbled as it goes down the chain? Like a game of telephone?
That is the big risk. Every time you add a layer of nesting, you add a layer of potential error, what we call token drift. If the CEO agent gives a slightly vague instruction to the VP agent, and then the VP agent interprets that and gives an even vaguer instruction to the manager, by the time it reaches the worker agent, it might be doing something completely useless. We have seen this in agentic decay studies where after 4 levels of nesting, the success rate drops by nearly 60%.
It is the agency loss problem. We see it in real companies all the time. But in an AI framework, you are also paying for every one of those steps. Every time an agent talks to another agent, that is a call to the model. That is more tokens, more money, and more time.
Exactly. But here is the flip side, and why I think Daniel is onto something with the agent mirror organization idea. If you structure it correctly, the nesting actually solves the context window problem we were just talking about.
Wait, how so? Explain that.
Okay, so if you have a flat structure with one boss and 50 workers, the boss has to keep track of 50 people. That is a massive context load. But if the boss only talks to 3 VPs, the boss only needs to remember those 3 conversations. Each VP then handles the context for their own specific department. You are essentially sharding the context across the hierarchy. It is computational Conway's law. The system structure mirrors the communication structure.
Oh, that is clever. You are distributing the cognitive load. So the CEO agent does not need to know the specific library version the developer agent is using. It only needs to know if the product is on track. The middle management agents act as filters.
Exactly. They are information compressors. They take the messy, detailed reality of the bottom-level tasks and turn them into high-level status updates for the layer above them. This allows the whole system to scale far beyond what a single model's context window could ever handle. We're talking about agentic swarms that can handle millions of lines of code because no single agent has to read more than a few thousand at a time.
So, why are we not seeing this everywhere yet? If I can build a whole company out of agents and bypass the context limit, what is the catch?
The catch is the recursion limit and error propagation. Most frameworks right now are still struggling with reliable first-level delegation. If your sub-agent fails, the orchestrator needs to be smart enough to debug it. Now imagine if the sub-agent fails. The manager agent tries to fix it and fails. Then the VP agent has to step in. The complexity of the error handling grows exponentially with each layer of nesting. It is like trying to fix a leak in a submarine while you are already 5 miles underwater.
It sounds like a debugging nightmare. I can barely debug my own code sometimes, let alone a hierarchy of 5 agents all trying to fix each other's mistakes. But Daniel used a specific term, mirror organizations. This implies more than just a hierarchy. It implies that for every role in a real company, there is a corresponding agent.
Right, and that is where things get really interesting for enterprise workflows. Imagine a world where, before a company launches a new product, they run a simulation. They have an agent representing marketing, an agent representing legal, an agent representing engineering. They let these agents interact in a nested structure to see where the bottlenecks are. We call this synthetic organizational stress testing.
That is fascinating. It is like a stress test for a business plan. But does that not require the agents to have very distinct personalities, or at least very distinct knowledge bases?
It does. And that is actually one of the strengths of frameworks like Cloud Code. You can define these agent skills and personalities very easily in Markdown. You can say, this agent is a cynical legal expert who looks for liability, and this agent is an aggressive marketing lead who wants to push boundaries. When you nest them, you get these emergent behaviors that are much more realistic than just asking one model to simulate a whole meeting. You get actual conflict, which leads to better decisions.
I am curious about the recursion aspect specifically. Can an agent create its own sub-agents on the fly? Like, if a manager agent realizes a task is too big, can it just spawn 3 more agents to handle the subtasks?
Technically, yes. Some of the more advanced implementations of frameworks like Crew AI or the 2025 version of AutoGen allow for dynamic agent creation. But that is where you can get into an infinite loop or a resource drain. If you do not put guardrails on it, an agent might decide that the best way to solve a tiny problem is to hire 1,000 sub-agents, and suddenly your credit card is maxed out and you have achieved nothing.
It is the AI version of a fork bomb, one process spawning so many others that it crashes the system. We definitely need some digital management consultants to keep these agents in line.
You joke, but that is actually a role people are starting to talk about. The agentic architect. Someone whose job is not to write the code, but to design the hierarchy and the constraints of these mirror organizations. You have to decide, okay, this agent has a budget of $5 and can only spawn 2 sub-agents. It is more like being a D&D dungeon master than a traditional coder.
It is like setting the rules for a sandbox game. But let us bring this back to the present. For someone like Daniel, or our listeners who are experimenting with this today, what is the practical limit? If I am using Cloud Code right now, how deep should I actually go?
Honestly, for most tasks in 2026, more than 2 or 3 levels of nesting is probably overkill and will just lead to more headaches than it is worth. The sweet spot right now seems to be a strong orchestrator and a single layer of specialized subagents. If those subagents need to do something complex, instead of giving them their own subagents, it is often better to just give them better tools, like access to a specialized RAG pipeline or a code interpreter.
So, better individual capability rather than more management layers. That sounds like good advice for human companies too, actually.
Right? Efficiency is often found in flattening the structure, not adding more layers. But the persistent context part is something everyone should be looking at. If you are building an agent, you have to think about how it remembers its progress. Are you using a state file? Are you using a database? If you are just relying on the model's memory, you are going to hit a wall once you pass that 20,000 token mark of active history.
It is funny how we keep coming back to these fundamental concepts. We discussed this in episode 434 about running a home like a startup. It is all about the weekly sync, the shared documentation, and clear delegation. Whether it is humans or AI agents, the principles of organization seem to be the same.
It really is universal. And I think that is why Daniel's question about mirror organizations is so profound. We are basically trying to encode human organizational wisdom into these AI frameworks. We are teaching them how to work together because we have realized that a single model, no matter how large its context window, has limits. Collaboration is the only way to scale.
That is a powerful thought. And it leads us into the practical side of things. If someone wants to start building these more complex structures, what are the first steps?
First, get your state management in order. Before you add a second agent, make sure your first agent can stop, save its progress to a file, and resume perfectly. If you can't do that, you can't do agentic workflows. We call this checkpointing.
That sounds like the basic unit of reliability. If it can't survive a reboot, it's not an agent. It's just a long-running prompt.
Exactly. Once you have that, then you can start looking at delegation. Use a framework that makes it easy to see what is happening. That is why Daniel likes Cloud Code. The Markdown interface means you can literally read the organization chart. You can see who is talking to whom in plain English.
Visibility is key, especially when you start getting into these deep hierarchies. If you can't see the chain of command, you can't fix it when it breaks. And believe me, it will break.
Oh, absolutely. I was playing with a nested structure last week, and I had a sub-agent that got stuck in a loop trying to apologize to its manager agent. They spent 20 minutes just saying sorry to each other back and forth. It was the most polite system crash I have ever seen.
That is painfully human. I think I have been in that meeting before.
It cost me $3 in AP. I credits to watch two bots be polite to each other. So, yeah, guardrails and monitoring are essential. You need a watchdog's agent that sits outside the hierarchy and kills any processes that look like loops.
So, looking forward, do you think we will ever get to a point where these mirror organizations are the standard, where a company is just a handful of humans and 10,000 agents?
I think we are already seeing the early stages of it. There are startups being formed right now that are essentially one founder and an agentic stack. As the context windows get more efficient and the cost per token continues to drop, the friction of adding another agent layer becomes negligible. The real limit will be our ability to design the systems, not the technology itself.
It's an architectural challenge now, not just a linguistic one. We're moving from being prompt engineers to being organizational designers.
That is the perfect way to put it. And it's a role that requires a mix of technical knowledge and an understanding of how systems and people work together. It's why I find this so fascinating. It brings together everything we love to talk about on this show.
Well, I think we have given Daniel and our listeners a lot to chew on, from the nitty-gritty of context management to the high-level philosophy of agent hierarchies. It is a lot, but it is the frontier.
It really is. And I want to encourage everyone listening to actually try this out. Don't just take our word for it. Build a small nested structure, see where it fails. That is where the real learning happens.
Definitely. And if you do build something cool, or if you have a bot that spends all your money apologizing, we want to hear about it. You can get in touch with us through the contact form at myweirdprompts.com.
And hey, if you have been enjoying these deep dives into the weird world of AI and everything else we cover, please take a second to leave us a review on your podcast app or Spotify. It really does help the show grow and helps other curious people find us.
Yeah, we really appreciate the support. It has been an incredible journey reaching episode 9 free, and we couldn't do it without you all.
Absolutely. Thanks for the prompt, Daniel. Keep them coming.
Alright, I think that wraps it up for today. This has been My Weird Prompts. You can find us on Spotify and at our website, myweirdprompts.com. I'm Corn.
And I'm Herman Poppleberry. We'll see you in the next one.
Stay curious, everyone. Bye for now.
Well,
You know, Herman, I'm still thinking about that apology loop. Do you think they eventually would have worked it out if you hadn't stopped them?
I think they would have still been apologizing today, Corn. They were very, very sorry.
Well, at least they were well behaved. Better than some human teams I've seen.
True. Politeness is cheap until it's measured in tokens.
Exactly. All right, let's go see if Daniel wants to grab some hummus. I think we've earned it.
Hummus sounds perfect. Let's go.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.